So, since I couldn't find the recorded version of us talking about this in class, I'm going to go ahead and make a new video. And I've tried to kind of cut out some of the intermediate steps to make it a little more straightforward. So hopefully this helps. And just to kind of remind us, this is from part 3 of activity 13.8a. And we started with a circle, which I drew here. And if we were in class, I would have had you all cut up the circle into 16 equal-sized pieces and then lay them out like I've done up here. But instead, I went ahead and did it, and I've pasted it into this Word document. But if you'd want to do it for yourself, I would encourage you to do so for sure. Just to kind of see for yourself how all of this unfolds. But just to kind of relate the two things that we have going on here, right? We started with a circle and we went to the parallelogram. And so if we're looking at the circle, like one of these slices, right, is one of these slices. And so the circumference of this circle, which I outlined in green, are these lengths of the parallelogram, which are also outlined in green, right? Both of these lengths combined add up to be the circumference of the circle. And similarly, in red, right, looking at the height of our parallelogram, that would correspond to the radius of our circle. Remember, the radius is half the diameter. And our goal here, we're going to look at how the area of the circle is related to the radius and the diameter. And we're going to start by looking at what we know about a parallelogram. And in this particular case, since I took this circle and I cut it up into 16 equal-sized pieces, and then I used every single piece of that circle, we can say that this parallelogram has the same area that this circle does. So again, this parallelogram has the same area that this circle does. And we know how to find the area of a parallelogram. Right? We know that the area of the parallelogram is the base times the height. And in this case, right, we've already talked about this, but our base, which I'll call B, is one of these green lengths. And since both of the green lengths together add up to be the circumference, right, we know then that one of the lengths would only be half the circumference. And our height, we said it earlier, is the radius, which is R. I called it R. So, in our formula for finding the area of the parallelogram, I'm just going to substitute these values. Right, so instead of H, I'm going to write R. Instead of B for base, I'm going to write half the circumference, right? Half C. And what I'm working towards, because you might be asking, well, why are we even doing this? What we're going to see, right, once we start doing this, because we wanted to know how the area related to the radius and the diameter of our circle, right? So as we start doing these substitutions, we're going to see the formula for finding the area of a circle come through. Like that'll be our end result. So moving forward, I'm going to kind of make a note. We know how to find the circumference. The circumference is 2 pi r. So instead of c, right, I'm going to substitute that with 2 pi r. So we have 1/2, and I'll write it in red to kind of keep it consistent with that note. And I'm going to leave r the same. So if we start multiplying things through, right, we have 1/2 times 2 pi r times r. 1/2 times 2 is 1, so those kind of cancel each other out. I'm just going to go to black now. So now we have pi r times r, which is pi r squared. Right, and that's the area of a circle. Right, that's our formula for the area of a circle. So, just another kind of rundown from top to bottom. We started with a circle, we cut it up into 16 equal sized pieces. The circumference of our circle are these two lengths in green, and the radius is the height. And we want to try and find the relationship between the area and this radius and diameter. Right, well, since we took that circle, cut it up into several pieces, we can say that these two things have the same area. So if we wanted to find the area of the circle, right, we could also just look at the area of the parallelogram that was formed when we cut up the circle. The area of our parallelogram is base times height. Well, we just got done saying that our base is half of the circumference, and our height is the radius. So instead of base times height, we wrote half the circumference times the radius. Then, since we know how to find the circumference, which is 2 pi r, we substituted c, which is the circumference, for 2 pi r, started multiplying things out, and we end up with the area of our circle. Again, this isn't something I'm going to ask you to replicate, but it is kind of cool to prove to ourselves, you know, and see where that area of a circle formula comes from. If you have any questions, please feel free to reach out via email, and I'll gladly answer them. Otherwise, I'm about to make another video that talks about the dimensional analysis a little bit more, since that was another one of the things that we talked about on Monday and I don't have the video for. So I will see you over there.